In this video, I'm going to be talking about representative binary ionics. Representative binary ionics are created with two different elements, the cation and the anion. The cation in the formula and in the name always goes first. Representative binary ionics are created with metals and nonmetals with subscripts. So in order to form subscripts, we must crisscross charges such as shown here. This 2 and -3 is crisscross between these two elements to create 3 in front and 2 in the second one. So for example, we have a look at barium chlorine, Ba2 and Cl1. In order to find those charges, we must look on the periodic table. Where is Ba on the periodic table? Barium right here. And its charge, depending on its valence electrons, is +2 because it's giving away 2 electrons. And if you look back, we have chlorine. And chlorine is all the way over here, as in Cl, and it has 7 valence electrons, and in order to get to 8, it has to steal 1. And stealing is bad, so it is -1 for its subscript. When we crisscross the subscripts, -1 should not be written. It should be assumed that there's a 1 there, and it shouldn't be negative, because you cannot have negative atoms. Invisible subscripts assume 1 atom. So that is the end result. So in nomenclature, cations keep their name, and anions change their endings to IDE, such as shown, barium chloride. Here we have some examples. We're not going to go through all of them, but we're going to pick some. Lithium fluoride to its formula is LiF, because Li is lithium right here, and it is giving away 1 valence electron. And fluorine, which is all the way over here, has 7 valence electrons, and it needs to steal 1 to get to 8. So, and 1 shall not be written in the formula, so it is LiNF. The cation, which is on the left side of the periodic table, will always be written first. Let's have a look at strontium phosphide, which is SrNP. Sr on the periodic table is right here at 2 valence electrons, so it has to give away 2, and giving away 2 valence electrons is good, so it's positive. And P, phosphide, is phosphorus, so they changed the ending to IDE. And if you look, we have 5 valence electrons for phosphorus, so it has to steal 3 valence electrons. And stealing is bad, so it's negative. And if we crisscross, we get that. And for the opposite, let's look at K2S. So K, we all know it's potassium, and S is sulfide. Well, S is sulfur, but in nomenclature, we change the ending to IDE.